Alright, hi class. Real quick, we're gonna do a quick introduction to the limit as x approaches infinity. So another part of understanding the behavior of the function is to understand the behavior of the function as x gets very large or very small, right? As it gets to positive infinity or as it gets to negative infinity. So we use the concept of infinity as a special idea to analyze the function when x is large or small. Infinity actually works great because infinity cannot be reached, but we can still try to work out the value of the function that have infinity in them. So here are um, a couple of guidelines that we can follow to interpret the limit as x approaches infinity. So the one that we want to focus here is for any positive rational number r and any real number c, right? So if you have c as any constant, for example, like a 3, and r is any rational number, like like 1/2, that as x approaches infinity, right? What the idea is that this number, as x approaches infinity, this number is going to be approaching a big number, right? A huge number. So, for example, let's say 3 over, and if x is approaching infinity, we can think about it as a number that is super, 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 super big, right? And if you take, let's say, the power of 1/2, that number is still going to be big, right? Very big, right? So you're going to have 3 over a huge number. And that actually number is still going to be, so if you try this in your calculator, let's try this in the calculator. Let's see, so if we have 3 over the square root, second square root of 10,000, we're going to go very, 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 very big, right? This is as x approaches infinity. And we press enter. This is saying that this is 3e to a negative 11. That means that this is like 0.000000000000003, right? So this number is very, very small. How small? Very close to 0. Right? As x even gets bigger, this number even gets closer to 0. So it does. So what I'm saying is, if x is approaching infinity and you have a constant over a number that is going to infinity, then this is going to be 0. The same argument follows even if it goes to negative infinity, right? It doesn't. It's still gonna. This number is gonna become negative infinity, right? But it's still, the number is gonna be negative 0.00001. So let's try that. Let's try this example. Let's try the same number, but now let's try with a cube root, right? So 3 over the cubed root. So let's say, where's the math? We'll try the cube root. And we have to use the cube root because we're going to use a negative number of a negative infinity, right? Let's see what happens. Not a real number, non-real answer. They didn't like that. Let's try. Of course it's not gonna work here, right? Maybe I used too many. Let's not get too excited here. Let's move over here. Alright, let's try this. There you go, right? It worked out, right? So, but you can see that the number is gonna get even closer and closer to 0, right? Let's try this again. Negative 1.000. Alright, there you go. Doesn't like it that much, right? But anyways, it's just gonna go to be negative 0.0000003, right? So anyway, they're gonna go to 0. Alright, so there are some guidelines that we have used to find the limits as x goes to infinity for rational functions. And we have two rules, right? We're going to divide each term in the argument by the highest power of x in the denominator, then find the limit at the infinity in the new form. So there's a video in the assignment that shows how to do that process, so we're going to skip that for now, and you can refer to that video. Please let me know if you have any questions.